And our final presenter today, before we hear the results of the vote, will be Dr. Christian Kuss, Assistant Professor of Chemistry.
All right. As the last one, I'll try to keep it short. I also try to make the pitch for scientists in science in general, and try to bring this a little bit into a full circle and provide context to the event. I think it was a fantastic event. I liked it very much, and seeing all this energy in the room. And we're doing this in the Faculty of Science, right? And as scientists, we're at the very beginning of the R&D pipeline, right? If I picture this as an inverted R&D pyramid, we're at the very bottom. We're doing the fundamental science. That's our call, right? Academic sciences. Who else would do this if not us, right? The basic scientific principles, but from those evolve a large number of different kinds of applications, right? And so we've seen a lot of those applications today that build on these scientific principles that we discover as scientists. Just to give an example of where this has been demonstrated very clearly is with conducting polymers, right? We've known about conductive organic substances since the late 1800s, but only in the 1970s, 1980s. Was research published that explains how we can get conductivity in organic substances and how we can get a conductivity along long polymer chains in conductive polymers. And because we understood this, researchers were able to chemically modify those polymers to try to tune their properties and make applications possible with this, right? And so researchers were able to tune the transparency of those materials, to tune their light absorption and light emission, their conductivity, their mechanical properties, and lots of different applications came from those, right? Like organic light emitting diodes, photovoltaics, printed circuits, supercapacitors, batteries, sensors. So really a plethora of different applications that come from this fundamental science that evolves into these applications. And because of this impact that the science has had, it's also earned its Nobel Prize in the year 2000 for the conducting polymer fundamental research. So what I'm trying to say is that the fundamental science needs to be supported properly to be able to evolve all these different applications, right? How we do this in my lab is we're working on electrochemically functional materials. We're producing new materials, discovering new materials, and try to understand how we can tune, by changing the chemistry slightly, the properties of those materials in order to, control their properties. The properties that we're measuring are things like conductivity, interfacial reactivity, mechanical properties, adhesion, processability, for example. And we're trying to find those connections to propose those applications from these materials. And you've seen one of those today, which is the application of our conducting polymer composites in batteries, right, as binders. But what you've not seen is that we've also applied for patent to use those same composites in pressure sensors, because we found that we apply pressure to those materials and their conductivity changes, right? Because we are looking at the fundamental properties of those materials. And at the same time, as we're characterizing the materials, we're developing new methods, right? And so there's different ways to now go forward with those technologies and develop them into products. One is through things like here, and entrepreneurship, right? And the other one is through partnerships. And there I will make the same pitch as Steve has done, right? We're always looking for partners, right, to progress the top bit of that pyramid and the applications that we can do with them. Thanks.
I think we have time for just like a quick question, because we do have the judges' decisions. Any questions?
I think everyone's waiting for the judge's decision, so I'll make room, and if you have questions, please feel free to come to me.